To begin creating my prototype, I'm going to need two different kinds of models in this case. On the one hand, I showed you that for structures of proteins or viruses that are known, I can actually go get some of the real data and use it as the starting point for my models. So this is really a way to use a more accurate source of data rather than to look at the image and model something from scratch. So if the data is there, I think it's definitely a nice thing to be able to use it. So back to the PDB, if you remember when we typed reovirus, it gave us a number of different possibilities. This is where some of the hard work comes in, and I'll skip over some of that hard work. But of the 24 entries, if you've taken the time to look at some of the papers, some of the publications that describe these different structures, so having done some of that reading, I actually know that it's the structure from that 2000 paper that I showed you in an earlier movie. That's what I want. So 1EJ6. So if I select that PDB ID 1EJ6, you can see that the page shows you just a number of different types of information about how this data was obtained. And I can also download the structure file. There are a number of different options here. I'm not going to go over all of them, but if you just download the regular PDB file, it will rather quickly get you the structure for the virus. So as this is downloading, a nice way to explore the structure of such a virus or protein is to use what's called a molecular graphics package. And many of these for academic uses are free. So a long-standing package, really high-quality package, is called Chimera. And Chimera, so I'll open it up and load the PDB for our reovirus. And so here it is in my PDB archive, 1EJ6. And when I click open, you'll notice that the program automatically creates what doesn't look like a virus in this case. So this is actually a different representation of proteins called cartoon or secondary structure, and I won't go into that today. But what you're seeing is what's called the asymmetric unit. It's only a piece of that virus. It turns out that if you know this one piece and you understand the symmetry of the virus, you can rebuild the entire virus based on just this one piece and some transformations in space, some rotations and translations of this one piece. So there's a very convenient tool in Chimera called multi-scale models. And so if you open that up, it brings up a little panel here. And what that will let you do is create the entire virus, what's called the biological unit or biological oligomer. So if I select all my chains and I then click on Make Models, you might need to wait a few seconds, but the program will create the entire virus structure. And this is starting to look more familiar now. And it gives you the beautiful virus structure that we saw in some of the pictures. You can even see how that one piece relates to the whole, right? So notice that that one piece that was open at first involves a piece of this five-fold turret, this pink turret, and also a part of this other layer. And if you multiply this 60 times, because it turns out this virus is an icosahedral virus, which means it has 60 copies of this particular asymmetric unit, you can now rebuild the entire viral capsid. So I'll stop here for this movie in terms of the virus, but what I did in creating the movie that I'll show you at the end is to create this mesh and then export it from Chimera as either a VRML or OBJ, and then I brought that into my package of choice, which is Maya in this case. And it was nice in that it let me build the virus, and I was actually able to import it. But the size of this mesh became really hard to work with. So I'll show you in the next movie, which is really about kind of refining your techniques and seeing what is going to be feasible in terms of production. I'll show you a different method, actually based on a tool that we created called Molecular Maya. But at this stage, this was the right way to build a prototype. Take an existing application like Chimera and quickly import and create a mesh of the virus and then transfer that to Maya. So that's for the virus. In terms of the microvilli, really nothing too fancy in the sense that with basic polygon modeling, started doing some tests to see what would happen if these microvilli were kind of swaying in the current. Tried different modeling approaches, extruding faces along a polyplane, also playing a little bit with a different shading, and in the end I settled on something closer to this look.